program. We are delighted to have with us Dr. M. Selvaraju, Head of Data Science at Cove.co with over 15 years of experience in the field. Dr. Selvaraju holds a BE in Mechatronics Engineering from Anna University, where he was a gold medalist in 2004. He earned his ME degree from Lordroad University, Australia in 2008 and later completed his PhD in computational mathematics from the same institution. With 6 years of experience working in AI in Australia, Dr. Selvaraju has extensively contributed to data science, AI, and analytics. Currently, as the head of data science at Cove.co, he leads AI-driven innovations across SaaS products. His area of interest include data analytics and artificial intelligence. We are honored to welcome Dr. M. Selvaraju to deliver a lecture on Introduction to Gen AI and RAG. We extend a warm welcome to you, sir.
Thank you, ma'am.
Thank you, sir.
Shall I start, ma'am, or is there any other formalities?
You can start the session, sir.
Okay, thank you, ma'am.
Thank you.
Excellent. So let me share my screen. By the way, for the interest of the participants, I have actually put the PowerPoint in the chat window. You can actually download it. So let me kick off. Cool. So let me kick off with what the session is going to be. By the way, people who could not get my video file, you can actually scan this QR code, or there is a URL link up there, which is also part of the PowerPoint, which you can actually scan to download the whole presentation. So what we're going to do in the next 90 minutes, just a bit of a session outcomes, what we want to achieve. So in next 90 minutes, you will be able to understand how a large language model works and how, most importantly, how it's been built. So that I will actually cover. Then I will talk about this interesting approach called RAG, which stands for Retrieval Augmented Generation, which most of the chatbots actually use. And then I will finish up with some insights about LLM vendors, the large language vendors like OpenAI and other players in this in the market. So let me give you a high-level overview of what's actually happening. So the way we actually access information is changing. Okay, it's happening right now. So if you look at how we actually used to look for information, but right now we go to ChatGPT for everything. So there are a few trends. The first thing is most of the people are they want to do things quickly. They want to achieve some kind of a task or an activity quickly. And they want some kind of information to be available anywhere, any device, and in any format. Okay. For example, if you go into ChatGPT and you put in a prompt and you want that to be in a bullet points, or maybe in a paragraph style, or maybe it's written in a more like a story way, in a story, like a story, you can also do that. Okay, so that's why it's all anytime, anywhere, and any device in any format. And it is the most important paradigm. They want accurate answers. Any question you put it into ChatGPT, they want accurate answers. So these are the typical kind of a trends that's driving into Gen AI. And people have choices. As I said earlier, the most important thing is when the customers access some kind of an information on the web, so they definitely want to look at different style and different persona. Maybe they want the output in a more casual way or a friendly way or more a professional way. So there are the choices in terms of how the information is being perceived is with the consumers now, like us. So let's look at how it's actually changing. So there is a big kind of a push for intelligence in terms of how these applications are actually evolving. It's no longer data driven. You need to have some kind of an intelligence built in. And the second important trend in terms of the automation, every little thing you think about is being automated end to end. And there's a big rise of web apps. And when you combine these three things together, it's actually giving a very powerful driving force from the technology front. And that's what you're actually witnessing in terms of this Gen AI. So when I say Gen AI, it stands for generative AI. So let's look at the different types of paradigms of how the search actually evolved over a period of time. So when we're actually using web, the internet, it was all for humans. And now it's no longer humans. You have to understand that there are a lot of bots in this paradigm. And most of the time, we actually discover content through these traditional search engines like Google, Bing, and DuckDuckGo. You name any kind of search engine, they were the primary content discovery platform. Right now, they have been replaced by ChatGPT, Gemini, Perplexity, Claude. Those kind of chat interfaces are coming into existence now. And if you look at the way the content is being discovered, you probably heard about a term called SEO, which stands for search engine optimization, where people optimize the content for certain type of keywords that we type in the search engine. Now, with the introduction of chat GPT like tools, it's no longer valid. Those practices are basically on the lifeline support now. And it is very clear we are traditionally using search keywords. So we go to Google, we type a keyword, and it gives you the bunch of links, and then we go and browse through each of the links to find whether what we're actually looking for in one of those links, and that's how we always discover the information. So that's where most of the traditional search engine actually sits. But these days, that is not the case. We go to ChatGPT and we actually issue a prompt or basically a question with some additional context in it. And guess what? It actually gives you the right answer. You don't have no longer have to sift through a lot of links and then try to understand. Probably there's no synthesizing of the data. The synthesizing of the data is done by ChatGPT like interface. So that's how we discover. And here's the thing. So always when we look for some information, we always do the work. But these days, it's all bots doing the work with us in the loop. So the paradigm is definitely shifting. Uh, so let's look at how it's actually shifting in terms of Gen AI. So I just want to give you an exercise, see whether people can actually unmute and then share something. Um, so here's the thing we're going to play, and anyone can take a turn. So if I say I, someone has to unmute and say the next word. Okay. And if you can't fulfill, just say full stop, and the next person can start the next kind of a word. Okay. You have to always start with the word. Okay. So I'm just going to start. So I'm just going to say I. Anyone wants to go next? Give it a go. What comes after I? Yeah. All right. Okay. So that's fine. So yeah. Yeah. Look, the other thing is cool thing you can do is type. Somebody typed am. Somebody wants to go next. You don't have to talk. Type. Somebody typed am. Is anyone wants to go next? Type what comes next. Just one word. Just do one word. Okay. Somebody said good. Okay. Okay. So the next is guy. Okay. So I'll finish the next one. Full stop. Someone wants to start the next sentence. Just one word. Just type in one word. You don't have to type in two words. Just one word. It could be a pronoun. It could be a verb. It could be a noun or anything. So now the sentence is I am good guy. Full stop. She. Who wants to go next? The next word is she. Is. Fantastic. She is May. Okay. She is May pretty. Okay. Full stop. Oh, okay, one more and then I will finish off. Okay. Okay, full stop. Try the next word. So the sentence is complete. But, okay. Rahul. Okay, go for it. So now the sentence actually hangs at but Rahul doesn't. Okay, but Rahul doesn't feel. Okay. But Rahul doesn't feel. Okay, let's stop there. Okay. So let's start how it actually opened. So I typed I and the next word is am. I am good guy, full stop. She is pretty, full stop. But Rahul doesn't feel, full stop. So what you're actually trying to do is you're trying to predict, correct? When I said I, the next word somebody typed is am. Nobody typed are or is or anything. So you probably know I is always followed by am. Okay. And then once you finish the sentence, is always a full stop. And when you type something like she is, there's a lot of combinations like pretty, beautiful, handsome, wonderful, and stuff like that. So there is some kind of a semantic structure to it. Okay. And when somebody typed, but Rahul doesn't, they didn't say Rahul don't. Okay. Usually when there's a third person singular, then he always starts with does. Okay. So that those are the grammatical rules. So what you've actually done is that's exactly how a generative AI actually works. So a generative AI in nutshell is an auto-completion in steroids. It's as simple as that. So when you type in a sentence like I am, what it's trying to do is it's trying to predict what will come next more in a very logical, grammatical way. Okay, that's exactly what a generative AI would do. And at the moment, with the capability we have with ChatGPT and Gemini, it can actually do 20,000 words in one go. So when you type I am, it can complete, it can actually produce 20,000 more words to complete the full sentence. Okay. And that's the generative AI in nutshell. So it's very simple to actually understand. Okay, so here's the thing. So the way that let's look at how that large language model gets built. So if I type something like the best thing about technology is its ability to. If I give you the there are only certain probability of words in the entire internet. So basically, you scrap the entire internet data and you're trying to find the probabilities of what's the next word probability after this word. Okay, so if somebody types the best thing about technology is the ability to, and you put a dot dot in ChatGPT, and the next word is connect, which actually occurred 26.24% in the entire in the corpus of the internet. Okay, and make is the another word, and then help is the another 6.33% probability. So this is how ChatGPT actually works. It's trying to predict the probability of the next word, and then you can actually choose if you choose a parameter called temperature in the LLM, and actually always choose the next word with the highest probability. In this case, if I choose the temperature parameter as 0, it's going to say 26. Okay, so here's an example, and I will show it in live as well. So if I say the best thing about technology is its ability to, you see this temperature parameter is set to 0. It's always started with connect. Okay. Now I change the temperature parameter to zero point 0.8. I type the same sentence. The best thing about technology is ability to. Now instead of connect, enhance actually pops up. And you see how those two paragraphs are exactly different. Okay, because it's trying to predict the probability of that word, the next word, and it's only choosing the least probability word and then to complete the sentence. So that's exactly how a Gen AI technology actually works. It's trying to predict, it's trying to auto-complete the word. It doesn't think, it's just a language model. It knows the semantic rules of the language, it knows the logical flow of the sentences. It's trying to, it can put up a paragraph with a logical connection of ideas. Okay, so let's look at where does this probability actually come from. Okay, it's very, very simple. So if you look at the whole English vocabulary, and this is the probability of each letter, okay, each alphabet in English. So we have 32, is it 32? 26. So the letter has 12.49% probability. So E occurs most often when we write, followed by T and A and O and so on. Z is the least occurring word alphabet in the whole English words. Okay, and this has been known. So if I give you something like I, let's try to say, let's try to form a sentence so that this probability distribution is actually fit. Okay, and this is the first sentence. If I try to generate something with that probability, so if you look at RRON, and if you take that, and it's exactly has E with 12.49 probability, and then T with 9.2, but it is gibberish. It is trying to generate something, but it's gibberish. Having said that, you probably know we can break into words with some probability. There are certain number of words with 3 letters. There are a certain number of words with 4 letters. If you split that, and this is what you get. Again, it's gibberish. It's not generative AI. But you also know the distribution of word lengths. Okay, for each word, what's the distribution? And if you try to use that as well, again, it's gibberish. It's not helping us at all. So I'm talking about just one alphabet. What if you have a pair of letters? Okay, you're talking about 2 grams in the traditional natural language processing sense. So you take 2 letters, and then this is the joint probability that looks like. Okay, then you clearly see U is followed by J. Okay, and then U is also followed by Q. So you get the sense of what actually follows each alphabet. Okay, and it's very clear. Okay, and then here it's very clear. If you use H, it's always followed by T. Okay, which is evident in a lot of these things. And E, if you put E, there are more probability that it is followed by H. And you can use the same, instead of one alphabet, now you use two, and now you can actually see it's able to form something like special, average, vocab, consumer, market, prepara. Okay, again, it doesn't make sense. Okay, and if you do it with n grams, okay, when I say n grams, right now we stick with 4 characters. That's when it's optimized and is able to form a complete meaningful sentence. Okay, here cat on a theory on and already, so it's actually trying to make a complete sentence, but still it is not semantically right. In a nutshell, if you look at not from a technology point of view, just from an abstract point of view, what the large language model is trying to do is, if I give you a large corpus of text data, what it's trying to do is it's trying to estimate probabilities. Okay, with 2 grams you got 1.6 billion. With ChatGPT 4 you have 100 trillion probabilities. Okay, so when you type something, it's trying to calculate probabilities of 100 trillion probabilities basically. Okay, the higher the model go, the probabilities actually increases exponentially, and the way they actually do compute this probability at scale, at speed, is unimaginable. Okay, so in a very small, in abstract way, a large language model is all about estimating probabilities of the next word. So if you give a large language, if you give the large language model a large corpus of data, it can actually self-learn, self-teach grammar, sentence structure as well, and is able to understand the context and relations. So if you put a man a man could be a king, a man could be a soldier. If you put a woman, she could be a queen. So it able to understand the contextual meaning behind that. Okay, and it's amazing how this contextual meaning is being built, and we will go into deeper when you look at the transformer architecture. And it can also traverse the path to autocomplete a sentence. It's very simple. It's trying to find the probabilities, and it's traversing through a bunch of words and it's trying to complete a sentence. Extremely simple. Okay. But the problem with this large language model is once it's trained, excuse me, when the facts change, LLM cannot cope. So just to give you an example, this is one of the question I actually typed. Who is the chancellor of Germany now? By the way, Germany doesn't have a chancellor now. I think they dissolved the parliament a few months ago and it is up for election. And it actually says the current chancellor of Germany is Olaf, who held the position since 2021. Again, it is not answering in a right way. Okay, it says is and it says since 2021. Actually, is not. Okay. And then look at how we actually correct this in terms of the LLM output. Yeah, okay, let me do a bit of a live demo. I'm going to type the same exact sentence. So let me share the screen. So here, so this is one of the, sorry, thing in OpenAI. It's called as a playground. So I'm just going to show you a playground where you can actually try to do. So here I'm going to keep this temperature as 0 and I'm going to hit run. So here, see, the best thing about technology is to connect. See, the word connect comes up. So that's the word. And I'm going to slightly vary the temperature. So this is how when it gets creative and it will pick the next probability word. Okay, so I'm just going to keep the temperature as, let's say, 0.2. Okay, I'm just going to keep. So now it says transform. So it picked the next probability word. In the presentation I've showed connect. After that, it's make, help, bring, and now transform comes up. Okay, so that's exactly how it actually predicts the next sentence. Yeah, any question before I move on to the next session? Yeah, okay, cool. So let me share my screen again. So this is session 3. So let's look at how they actually build this transformer. So I said I actually shown you how this actually works. And in abstractions, I actually given you more in terms of how probabilities are being calculated and stuff like that. So the way it actually works is by a traditional Google paper. Okay, this was published back in 2006, I guess. So the name of the paper is all. So attention is all you need is the name of the paper, and I've actually given the link to that paper as well. So this actually is the one, it actually proposes the network architecture called transformers. Okay, it is a very important thing. So let me give you a high level idea about how the transformers actually work. Okay, so okay, next slide. An idea. So if you look at transformer architecture, what it's trying to do is it has some kind of an encoder and a decoder. And by the way, the machines don't understand text, which means you have to convert this text into a string of numbers, okay, which is called as an embedding process. So here, an encoder takes a string, in this way, it's actually taking a string of numbers. Okay. And it goes through the decoder, and the decoder produces an output. So if you think about a way, if I say I am, it goes to the encoder, and the decoder will say I am a student. Very, very simple. And the way it actually works is, for each of this thing in an encoder, there is something called as a self-attention, and there's a feed-forward loop, which is basically a RNN. Okay, it's a recurrent neural network. The self-attention, the feed-forward, and you have the exact kind of the same thing in the decoder, except that you also have a encoder-decoder attention layer attached to it. Okay. Um, So the way it actually works is uh, you give an input, and when I say input, embedding here in this diagram, which is basically converting the text into string of numbers, and then there's something called positional encoding. So it'll actually look at every position of your word, okay, where those are the tokens actually occurs. A token is nothing but 4 characters, okay, and then it's trying to adjust the weight of the RNN so that it's trying to find out, calculate the probabilities, okay, in a very nutshell. So that's usually how an encoder actually works, and the reverse actually happens on the decoder side as well, okay. So that's the very high level idea about how the transform architecture works. But if you need specific information on how it actually works, it involves a lot of mathematical theory. Um, for uh, for this 90 minutes, I just want to keep it brief. That's why I'm actually giving you a high level idea about how it actually. But if you go to this paper, they can actually give you much more information on how the transform architecture actually works. And all the LLM vendors, when you take ChatGPT or Gemini, they all use transformer architecture, by the way, for training their large language model. So let's go into session 4, which I want to talk about more in terms of LLM versus RAG. Okay, so LLM stands for large language model, which I've actually shown. There are a lot of providers out there like OpenAI. RAG stands for retrieval augmented generation. So when you build an LLM, you go and look at all the corpus of data in the internet, or you have your private repository, or any kind of a source that has a world knowledge in it. And that's how you use it to train your large language model to compute your probabilities, and more importantly, they're trying to compute the weights of your RNN. Okay, so that's exactly what actually happens. But if the facts change, for example, when you train the model, the president of United States was Joe Biden, but right now we have a new president. So when the facts change, the large language model cannot cope. Okay, it's basically it's going to bluff, or it's not. It doesn't have the information to tell you. So in that case, you can actually augment the information using this approach called RAG, which is the main topic for this day, which stands for retrieval augmented generation. So you actually augment the existing obsolete knowledge in your large language model with the new knowledge. So it's very simple, kind of an abstract way. There is also another thing about LLM. You can also fine tune a large language model. What I mean by that is, you can take a large language model, and let's say you are from an educational domain, like academicians like you. So you use certain terms differently. For example, instead of an article, you might say a lecture. Instead of a Word document, you might refer in your thing as a curriculum, um, um, or a lecture plan. And those are very business domain specific, and you can actually use it to fine tune a large language model so that it can actually understand your domain better and can actually give you a lot more accurate output using your domain language. So it's very easy to actually understand RAG architecture. So whenever you use a RAG approach, you take some kind of a trusted source, some kind of a knowledge base, or some kind of a repository, a knowledge repository, and use it to produce a tailored response. Okay. And there is something called as a system message in the RAG framework, which actually provides a guideline of how the LLM should behave. And that sets the whole context for a large language model of how the RAG framework should work. Um, so in many cases, if you type it in some kind of a chat bot, you might have interfaced with any of the websites you go to, like e-commerce and things like that. It always gives you, I do not know, if it couldn't find any information. So if it cannot respond, respond, it instead of saying, instead of hallucinating, when I say hallucinating, the LLM is trying to lie to you. But instead of that, it might say, I do not know. Okay, so that's the typical kind of a behavior of a RAG system. So before I go into RAG, there are a few concepts you need to master. The first one is called tokens. So anywhere you go into Gen AI space, they always use this term called tokens. A token is basically a 4 characters. So that's exactly um, how you pass your uh, uh, text data and then convert it to numerical data and then pass it on to RNN. So one token is basically a 4 character. Okay. The second concept is called a word. A word is 100 tokens. If you take 100 tokens, approximately it's about 75 words. Okay, so that's usually the norm. And if you take a paragraph usually about 100 tokens. Okay, so that's usually the concept in um, generative AI framework. And this is how exactly most of the Gen AI chatbot and any of the things that you see in the websites, e-commerce, or even in WhatsApp actually works. You have some kind of a source, which we call as a knowledge base or a knowledge repository, and you pre-process. Basically, you extract all the HTML content from the internet or from your database, and then you pre-process the content because it has a lot of this additional parameters like CSS. You remove it, hyperlinks, any kind of formatting tags like bold, strong, italics, those kind of stuff. You just pre-process and remove them, and then let's say you have like 10 paragraphs, and then you have to split those into some kind of a smaller chunks. So every 500 tokens, you chunk them basically. So assume that you have um, 10 pages of content, and every 500 tokens, you chunk them and then store it. Okay, so that's called as a text chunking basically. And then with the text chunk, you convert them into something called embeddings. So all those, because machines can only understand numbers, then you convert those text chunks for each text chunk, you convert into something as an embedding. The way to do that, the way to convert those text information embedding is to use some kind of an API. So you're probably familiar with APIs. So there's one of the famous embedding model is OpenAI's text embedding ADA 2. But they're also coming up with this version 3 and version 3 large. They also upgraded the embedding model as well. And what you do is you send an API call to OpenAI with the text embedding REST endpoint with the text information. And basically, OpenAI will return a string of numbers. And the dimension depends. So usually the dimension is about 1536, and it can go all the way up to more than 3000 as well if you want more accuracy kind of an embedding. Okay, so that's usually the case. And then you store these embeddings in some kind of a vector database with the article reference. So each chunk, and then you have the embedding, which is the numerical representation of the text basically. And you store it in a vector database. It's not a normal database. You have to store it in a vector database. The reason is you got to do some kind of a vector search, which I'll come to it. So this is how you chunk the information and store it. Let's say somebody comes and asks the question about the data. Okay. And then you convert that question into an embedding. Very simple. Again, use the OpenAI embedding API, and you get the embeddings. Then is the very interesting part. The questions embedding, which is the string of numbers, goes and searches against all the embeddings you have for the whole document. Okay, you might have assume that you have 8 page document, and let's assume that it's split into 100 chunks, because you take 500 tokens, it's split into 100 chunks. And basically what it's trying to do is, once you have the questions, it's going to do a search and then trying to find out what are the text chunk that is relevant for answering this question. And the way we do that is by calculating a distance metric. Okay, and one of the distance metric that is used for semantic matching is called a cosine similarity. Basically, you have a vector of 1036 in your, you have series of vectors. In this case, there's about 100 chunks you have 100 embeddings, 100 vectors, and the question comes in, which is a vector 1, and then you do this cosine similarity. Okay, basically taking the cosine angle between those two vectors, and then you are actually sorting them and then picking up the top 5 chunks, the one that actually has the highest similarity, which means the highest cosine similarity value, and you pick the top 5, and then you send it to OpenAI. Okay, and then it's trying to answer that question with all the context that you actually, when I say context, all the 5 chunks that you've actually returned, and that's how it's trying to produce a response. Okay, for building a response, you can actually use some kind of a text Da Vinci model, or in the recent one, they have ChatGPT 4 Mini or ChatGPT 4 Turbo. Those kind of models can be used for the chat completion. Again, the response is very similar to the demo I have actually shown. Basically, you are setting the problem as a more of a token prediction. Okay, you're sending this question and you're sending this chunk and you're trying to predict what comes after that. Okay, and the OpenAI large language model is trying to predict what comes next to that. So the important aspect I want to cover is in terms of the distance metric. The cosine similarity formula is very similar. It's not a lot of mathematics. It's cos theta is A dot B divided by modulus of A and norm of A and norm of B. Okay, very simple formula. And you know how to calculate A dot B. You're basically doing the element-wise multiplication and you're actually summing up. Okay, so that's in the numerator. And the denominator is basically you're taking a sum of squares of those each vectors. Here's the important thing. So this is a cosine similarity formula. This is how you calculate the distance and you pick the top 5 chunks. Most of the time, the data that's coming out of OpenAI, they are normalized, which means the norm of A and norm of B is 1. So 1 times 1 is always 1. So in this case, cos theta is A dot B. So when you do the dot product, it's essentially doing the cosine similarity. And dot products are easy to compute because you're just multiplying and adding. Okay. So that's usually gets implemented. So when I say cosine similarity with a lot of these things, underlying the way that the algorithm gets implemented is especially essentially using dot product. Okay. And then you can also calculate Euclidean distance, which you know the L2 norm formula. That can also be used to compute the distance metric as well. But cosine similarity is what's mostly used because you're mostly concerned about the similarity, okay, how close they are. If cos theta is 0, which means they are one and the same, they are exactly the same kind of vectors. If it's 90, it's orthogonal. If it's -1, they're exactly at the different end of the spectrum. Okay. So let me give you a perfect example. I will also show you a live demo as well. Here, there is a question called what is document status pricing plan? And this is just an example, and I can actually give you another example as well. So this is the question I typed into the chatbot, and this is the response it actually provided. Okay, let's look at how it's been constructed. And most important thing is when you look at all these things, usually there's a set of articles that are actually used. The top 5 chunks, basically, the top 5 chunks come from these 5 articles. Okay, and it's used to compute to formulate the response. Okay, let's look at it how it actually does. So the first line of the response comes from the second chunk and second article, which is this chunk. Okay. See, it's actually saying documents is a knowledge-based platform, and but the response, it doesn't say knowledge base is a knowledge management platform. It says documents is a platform. Okay, again, it's trying to rephrase. If you look at the second line, that comes from another article, from another chunk. Okay, here you see it's all in bullet points, but here in the response, you can actually say it's in the comma separated values. Okay, and then the third and then the final one comes from the other article, from the last kind of a chunk. Okay, so it's trying to piece together different information from different article and then trying to generate a response. Okay, it's extremely simple and easy to understand. Okay, let me show you a live demo. So by the way, these technologies are everywhere. It's around us. I just want to show you one of the cool thing that we have actually built. So here is one of the chatbot in any of the platform that you use. So here I'm actually going and typing something like what is document 360. Okay, and I'm just going to start a conversation. Again, it's just a chatbot. And if you look at it, it's also giving the same answer. Document 360 knowledge-based platform, knowledge management platform. But here's the most important thing. It actually gives you an inline citation where it actually pulled from. Okay, what are its pricing plans? And its AI features. Okay, I'm just going to ask a follow-up question. See whether it's able to give you a little bit of a context on which chunks it's actually picked and where it's actually coming from. Okay, now here we go. Now it's actually putting a table. Excellent. And this is coming from source one. Excellent. And it's also putting another table, and it's actually saying it's coming from source two, which is upgrading your subscription plan, which is fantastic. That's exactly what we needed. So this is how it actually stitched together two pieces of information and then put it there. Any question? No? Okay, no worries. So let me continue. So let's look at how the semantic search powered by Gen AI is different from keyword search. So if you put it in Google, it actually uses some kind of algorithm called BM25, which is best match 25, which is a lexical based search engine. Okay, when you type a keyword, it's trying to find where those keywords are happening. This is based on a natural language processing technique called, which is an evaluation from an NLP technique called TF-IDF, a term frequency, inverse document frequency. And the semantic search I was talking about, it's actually finding similarity. It is not matching keywords. It's actually finding semantic relationship between those entities. To give you a best example, let's say you have a content and you mention something like United States everywhere, but your customers are actually coming in and um, typing something called America. It's very hard to find because your search engine will actually fail. Okay, but you know that United States and America are actually related. Okay, and that's exactly when the semantic search actually shines. Okay, so there's one question from the chat. Can you tell me how I can make timetable of different sections by using Gen AI? Make timetable of different sections. Are you okay? So if you're trying to find the timetable of different sections, I mean, you're trying to find which time interval or which time stamp that somebody um, is actually taking a session or something like that. That is a different optimization. Okay, yeah, that's a different optimization. Gen A cannot do that. As I said, that's a linear programming optimization problem. Gen A can only autofill what's coming next. Okay, unfortunately, it cannot solve the timetable problem, sir. Yeah, you need to look at linear program. Yeah, cool. So here's another example I've actually given you. When you type like D360 and something like that, it cannot find the search. But when you type an AI chatbot, it's able to understand those nuances. So here is an example of how it actually works. So when you go to ChatGPT, one of my recommendation is do not type a search keyword because it actually requiring a prompt. Okay, because when you type a search keyword, it's very hard for the algorithm to understand the context. What do you mean? Okay. Um, So to give you an idea, so in the traditional sense, you use search keywords, but when you come to Gen AI, you have to prompt it. So that's why there's a new technique, new skill set called prompt engineering, and you have to give a lot of context. And guess what? The large language model based generative AI is always slow. It actually takes time, and you actually witnessed in ChatGPT as well. When you type a question, it takes a few seconds to actually generate an answer from. That's the nature of it because it has to go through compute those probabilities, find the sentence, and then give you the more cohesive output. And it's more semantic based matching. Um, cool. Um, okay. So let's look at how the RAG actually works in terms of this context. So it's actually trying to understand the semantic nature of the query. Okay, it's trying to understand the intent of the user, and then it's trying to do the semantic matching using the cosine similarity, and that's exactly how the RAG system actually works. Any question before I go into step session 5? Okay, cool. So let me go into this. Uh, okay, cool. So thank you, ma'am. I think you were actually asking about hallucination. Let me go into in depth in detail about what actually what is hallucination. That's the topic for next one. So the term hallucination means the generative AI model is actually creating something that is not factual, to put it that way. The reason why it actually does that, it's actually inherent in the large language model because it's trying to predict the next word. It might not know whether what's the importance or whether there is any logical misflow in terms of how the information is being given out. So that's why it might not be accurate. Okay, and that's why and that is being referred as a hallucination. Um, and there is no strategies to reduce a hallucination. So you probably heard about Google generative experience called SGE when they rolled out, or when someone typed how do I make a pizza or something, it actually said you have to add glue to make the pizza stick. Okay. And that's a typical kind of a hallucination. There is a lot of funny memes around how ChatGPT and also Google Gemini hallucinated. It's impossible to actually eliminate those hallucinations. It's always inherent because the inherent nature of the large language model. Same with humans. If you look at human, irrationality is built in. We think that we are a rational human being, but we also make irrational choices. Okay, it's extremely hard for even for a human being to be rational all the time, even though we are like that. We can explain how the irrationality actually works in the human, but with ChatGPT, we can't even predict how it's going to behave. So that's the problem. Okay. But having said that, if you have some kind of a RAG system, retrieval augmented generation, you can put some guardrails. And if you think that it generated a response, but it is not confident enough to say that that response actually answered a question, then you can always come and say, you know what, I do not know. Okay, so that's the kind of a way you can actually think about. Okay, let me show you one chart. Okay, so this is the usual kind of a context when you talk about hallucination. So when the information is available and your generative AI produce a response, great. So you are in this right answer. Thumbs up. Good work. But having said that, if there's no content available and your generative AI comes and say, hey, I do not know or I do not have the information, that is also valid. Good on the Gen AI. But the problem occurs when the answer is available in the content, it produces a wrong response, or the answer is not available and still it produces a response. Okay, and those are the typical cases of hallucination. And this has been a problem with all this generative, the large language model providers, and what they're trying to do with this pre-training and then this other kind of sophisticated techniques. They're trying to reduce the hallucination happening in the large language model. Okay. So again, given that there's a lot of hallucination, how do we actually evaluate Gen AI? Okay, how do we know that what ChatGPT is giving you is the right answer? The way we do that is through some kind of an eval. Okay, it's called as an evaluation. And OpenAI, they also revealed some kind of an eval framework. It's called evals, and they also call general QA, which they recently released. So the way they actually do that is with these three criteria I've actually given you. And using that, it's trying to find an accuracy of how good it is. Okay, and it is an open source project. It is available in GitHub. When you click on the link, you can actually download it. And to run this evaluation metric, you need something called a ground truth. So that's how you evaluate the generative AI response with the ground truth, which means some of the humans have to write the ground truth. Um, and they have this nice little Python library called Match, includes, and they also do fuzzy matching as well. So, and it actually gives you a metric score. And the other emerging framework is called Ragus. They also look at OpenAI, the output of Gen AI through this context called faithfulness, answer relevancy, precision, and context recall. Okay. Any question on the evaluation before I move into session 6? Yeah, cool. Okay. So there are some trade-offs I want to talk about. One is the question versus response time. Okay. Um, how much time it takes you to ask a question and how much time it takes you to respond. And the second trade-off graph is called the number of tokens it actually produces and then the number of time it actually takes it to produce those tokens. And then the input tokens versus response time as well. So let's look at some of the cool graphs I have. Here is the output tokens versus response time. So if you look at this, so the more number of tokens it actually produces, the more number of words it actually spits out, it takes longer time, which is obvious. Okay, which means it actually imitates humans. When you ask, the more words we talk, the longer it takes for us to actually finish the whole sentence. So that's actually very evident here. But here's the important thing. Even if the question, so the type of question actually determines how long it actually produces a response. To give you an example, if I ask you a question, are you from America? The answer is no or yes. Yeah, sorry, apologies. Cool. So, if the question is very short, if I ask you a question like, "Are you an American?" and you'll probably say no, so the response time will be quicker. But if you ask you a question, "Hey, what did you do when you are at the age of 10? You are at school and on this particular birthday," then you got to think a lot, and then it takes time. So that's why you clearly see the shorter the question is, but sorry, the um, depending upon the type of the question, the response time will differ. Okay, it's very simple. So as I said, this is a summary of how it actually works. We take more time to respond when asked how and why question. We also take more time to generate a lot of words. Okay, and the most important thing is the even if your knowledge is has a good quantity, doesn't mean that it actually affects the good quality of the output. Okay, it's extremely important. So the more important thing is the quality of the question, the quality of the knowledge, the quality of the prompt. Everything determines the accuracy of the response. I think I covered hallucination in detail. Um, yeah, covered. And before we do, there's something called a moderation API, and that's how they draw these ethical boundaries around Gen AI. All these vendors, they actually give them this moderation API free of cost, and you can actually use it as well. A part of that. So what it actually does is it actually checks against violence, harm, self-harm, those kind of aspects. And if it flags that question falls into that bucket, then it actually gives you some kind of an output. Okay, and the moderation APIs are free to use as well. Um, that's pretty much I have in terms of the session 6. Any question before I move on to the last session? Okay. Cool. So there's a bit of a demo I have as well, so which I'll go next. Um, so if you look at generative AI, there is only few companies that's out there which produces the large language model. The reason is very simple. It takes millions of dollars of compute to calculate those weights of this RNN. And some of this RNN model have more than 40 billion parameters. So it takes a lot of time number crunching to create an RNN model of that size. Okay, and only few companies in the world has compute and then the capital to do that. And one of the company that pioneered this is OpenAI, and you probably heard the news. And they are very famous for their chatbot model called ChatGPT, um, and they came first to the market. And then you have this other providers called Anthropic, Cohere. Anthropic does something called Claude, which is a ChatGPT equivalent web UI chatbot version. And you also have Perplexity. Um, And Cohere also has similar mysteries on another player in the LLM uh, domain. And these four players, or some of the most of the players, they are proprietary technology. They will not tell you anything about their training data, any of the technology stack they actually use, how they actually use the transformer architecture, and how many GPUs from NVIDIA they actually used. They are all trade secrets. But there are some papers available in training a rudimentary kind of a large language model until Meta AI released an open source large language model completely free. As an academician, you can actually go and download and then look at the weights as well. It is called Llama. Okay, and the recent one is Llama 3.1. And the people are actually hinting at the Llama 4 is also coming, which they think about multimodal, and it can do a lot more other cool stuff. If you're an academician and if you want to get into a large language model space and you want to use it, or if you want to do some research, Meta AI is a great kind of resource for you to learn about large language model. Okay. Um, so that's pretty much I have. And one thing I want to show you before I finish off is Um, is a small demo, and then we'll take a break. Uh, share my screen. So what I'm actually showing you here is a playground. Okay, this is being done by OpenAI, and this is a very paid version. Until you have a paid version, you can't use it. This is different from the Chat GPT. Okay, but it emulates what it actually does. Okay, this one you got to pay, and that one is free. For example, if I type something like here, it's actually exactly the same thing. Here I cannot control what comes next, but with this ChatGPT playground, this actually emulates the API. In the API you have all this information, temperature, max token, and all these things, which I will cover in the next session anyway. But this is very different. The OpenAI playground is very different to the ChatGPT. Okay, the other one I want to talk about is the Claude. This is another piece of ChatGPT like interface from this company called Cohere, and this is pretty good. In fact, like ChatGPT, you have this ChatGPT 4, 4 mini model, and Claude. They also have HiQ and Sonnet model. And let me type the exact same thing, and then I'll Okay, here we go. So it's able to do. So let's ask something a cool question. Okay. I'll say what is Atal AICTE program in India? Okay. Let me ask the same question. Let's see whether it's able to figure it out. Okay, that's pretty cool. So here we go. So it says awareness training, learning and initiative by AICTE. It's fantastic. It's able to pull it out. But let's also look at what Mr. Chat GPT is going to say. Okay, it's also able to pull. But here, if you can look at it, ChatGPT also have some kind of a search functionality. I can also use that, and then I put the same question. Now, instead of using its own model, own LLM model, now it's searching the web and it's trying to find this information from the internet, and it's able to answer that question in a lot more elaborative way. See, it's able to do that, and it's able to cite where it's actually pull the information from act-india.org. And it's able to give this inline citation of where it actually pulled from, which is fantastic. This is usually how it actually works. So let's ask a question. Who is the uh, chancellor of Germany now? Okay, now I copy this question. Now I'm using search. Okay, this is the retrieval augmented generation I was talking about. See, now it's actually using the web, and it says that he serves. Okay, as of and you resumed blah blah blah, and it's able to do that. Let me turn it off, and then I'm going to ask the same question. Again, it's going to the search. Okay, no worries. Now let's ask Claude the same question. Um, okay, okay. It says it's unable to. Okay, it says he's currently the thing. Okay, so let's ask another thing called perplexity.ai, which is a very different. It uses RAG in a more much elaborative way. And if you use this, and you can clearly see this one is a lot more powerful. Okay, and here it says Olaf has been. Okay, and he's the head. Cool. He was elected, but his government majority collapsed. Okay, um, so there you go. So these are the different type of paradigm how it use. Anyway, if you go into any kind of platforms. Like let me look at one of the famous product, let's say Monday.com. Okay, they have chatbots everywhere, and even in fact, I'll say Chatbase. So everywhere, any website you go into, they uses this chatbot, and all uses this large language model, and also the RAG framework, which I talked about. So let me show you this another company. See here, the chatbot, and it's able to ask the question. So it also gives you a bit of a question to start with. If you don't know how to do prompt engineering, and you can actually type what is Chatbase, and it's able to find a response. Okay, and I can actually say how much it costs. So definitely Gen AI is actually changing the way we interact with the information. Yeah, cool. Any questions before I take a small break and then come back in another 5 to 10 minutes? Yeah, any questions before we leave for a break? Any questions? For people who actually joined late, if you scroll up to the top of the page in the chat window, I've actually given you the whole PowerPoint presentation. You can actually download and reuse, and then you're free to use that PowerPoint. Yeah. Okay, so there's one question in the chat window. What are the key use cases of RAG in industries like healthcare, finance, or education? So the key use cases, okay, let's look at healthcare, which is a very interesting domain. Instead of calling a doctor, you can actually put your symptoms in the chatbot, and you can actually ask, okay, I'll share it again. There was a request to share it again. Um, Yep, I shared the PowerPoint again. So let me talk about the interesting use case in healthcare. I assume that you have some kind of a symptom. Let's say you're feeling dizzy or something like that. And instead of calling a doctor or going to the doctor and waiting in the line, all you got to go to this chatbot, and you explain all your medical conditions um, clearly, and then the chatbot might be able to diagnose, okay, or provide some kind of early diagnostic on what you need to do. Okay, so that's the typical use case we see in healthcare, more like a self-help or um, more like a nurse kind of a role it actually plays. In education, oh, this is massive use case. Think about it. If you can make all your lecture material apply um, to a chatbot, and then the students can actually learn more iteratively. They can actually ask follow-up question. They can actually get more deep into some of the concepts and stuff like that, which is pretty much what we needed. Okay. Again, it also applies for finance. Is very tricky. Finance, if you look at it for the banks, they throw all their compliance document, and then if RBI introduces a new compliance or stuff like that, they can actually ask a question and try to understand what they need to do to comply. But a large language model, just remember, it's a large language model. It's very bad with mathematics because it's very bad with numbers. It's actually predicting. It's not doing any logical computation. So large language model is more of a language model. It's not a mental model or a mathematical model. When I say mathematical model, it cannot do math really good. So there are a lot of tweaks under the hood people do with a lot of LLM providers to ensure that they can do math. For example, with OpenAI, when you try to put in a mathematical question, it calls a Wolfram Alpha under the hood, and Wolfram Alpha returns the result as well. Cool. Okay, so there was one question. How Gen AI applicable in video generation? Okay, so I want you to type something called Sora. So go to this site called Sora. If you type Sora OpenAI, okay, let me also give you the link as well. So the video generation is really, really cool of how they actually generate a video with audio inputs and visually just using a prompt. Okay. This is a very interesting piece of technology. People are actually saying that this is going to revolutionize the entertainment industry, how we make videos and stuff like that. So just using one prompt, it can actually build videos. Again, it is based on the same architecture, like a transform architecture. Right now, instead of giving one-dimensional data, you have multimodal data, you have audio, video, text data all going to the transformer, and that's the complex encoding part. Okay. um, and if you look at Sora, the videos are stunning. It's a lot more interesting. It's very it gives you this immersive experience. And video generation is definitely is definitely going to revolutionize those things. And you can actually see that in WhatsApp. You can actually send. You can put a prompt. You can actually create a animated GIF or something like that. You can actually send. And many B2C apps are trying to incorporate those kind of technology as well in their application. Yeah. Any question before we take a break? Excellent. So we'll take a break. At the moment, the time is 20 past 7. So we will convene at half past 7. Okay, 7:30. Then we'll start this hands-on session with building a chatbot. Yeah, cool. All right, thank you so much. I will turn off the video and I will join in 10 minutes time, 7:30. Thank you.
Thank you everyone for your active participation and attention during this session. A special thank you to Dr. Selvaraju for his insightful lecture on Gen AI. Before we move on to the hands-on session, I kindly request all participants to fill out the feedback form available in the chat section. Let's take a short break and we'll resume at 7:30 p.m. See you all shortly. Thank you.
via mobile. Thank you. So since many of you are joining via mobile, it's very hard to do a hands-on session. Given that if I give you some kind of a Python program, it's very hard to for you to type. And the other thing is, if you have encountered any errors, I can't troubleshoot for each one of you, given that there's a lot of participants here. So the way I'm trying to do is, I will just show you how it's been built, then you actually get to understand. And I will show you each step how it's been built. Okay. Cool. Um, so let me share my screen. Uh, By the way, if you need to contact me, that's my LinkedIn. Once you finish, if you have any kind of future queries, ping me in LinkedIn. I should be able to answer, send you some reference or any kind of help that you need. Cool. So, cool. So this is a bit of a hands-on session, which is exciting. And what we're trying to do with this hands-on session is I'll show you how to build a chatbot, okay, in a real life, in a world. And then we'll go deep into something called text chunking strategies. Then again, I'll come back and revisit this RAG framework, which I've mentioned in the last session. And then we also look at some kind of a prompting techniques. Okay, cool. Let's dive in. So the chatbots are very interesting. And if you are really into computer science and then you actually build some of the cool stuff over the years, and you probably heard about this framework called RASA, RASA. This is again an open source framework that's been built, and a lot of companies during those days when the dot-com boom came into being, and they were actually trying to build a chatbot using this RASA framework. Okay, um, and they also have Microsoft Bot framework as well, which came after RASA, and there's a lot of companies who try to use. And but when I say a chat bot, you're talking to a machine. Okay, it's very different to WhatsApp. In WhatsApp, it's a human-to-human chat. Okay, but with chatbot or a bot in general, you're trying to talk to a machine. Okay, or an AI system, and that's what a chatbot generally refers to. Cool. So with Rasa, when it was actually introduced, it was quite good in the early stages, but it had a lot of problems, okay, which made chatbot a lot unreliable. And I'll tell you why. With Rasa, it needs constant model training. It is not based on a large language model. It's based on some kind of a neural network, but there are a lot of problems with model training. Okay, you need a constant stream of data coming in and training this model, and its accuracies was very poor. It's all limited to the number of data sets you have. And what he is trying to do is trying to paraphrase some of the interesting things, or it's trying to find the exact paragraph where there's actually word match, and it's trying to rephrase it. Okay, that's exactly some of the things you're actually able to do. It has limited accuracy in terms of the response, which makes it unusable. The other important thing is to make Rasa actually work in a software or in a web. There's a complex deployment process you have to do. Okay. And Rasa was originally a framework. It never had a front end. You, as a developer, you have to build that user interface on the top of Rasa. Okay, these are like a lot of challenges with Rasa. But with OpenAI, it actually solved the problem. And people actually mentioned this. Um, I think it was released in October 2022, and the world actually changed after that. Okay. The modern chatbots are based on large language model. They are all LLM based, which means they actually understand the whole language component of it. It actually knows how to semantically structure a sentence or a paragraph. It knows how to logically build arguments. It doesn't make any spelling mistakes or typos or grammatical mistakes, and it's all very apparent. Okay, and the most important thing is when OpenAI introduced chatbot, the ChatGPT, they also released a bunch of flexible APIs, which means you cannot. They actually empowered everybody in the world to actually create chatbots using their proprietary technology. Okay, so they introduced a lot of, they shipped a lot of flexible APIs. And the other thing that revolutionized this thing is with Rasa, there's a lot of cost involved, but with ChatGPT, it's extremely simple to use and it's extremely cheap. You wouldn't even imagine how much it actually costs to run a simple inference query in ChatGPT. Is extremely cheap, and most importantly, given this is a bit of a API, they're all developer friendly. Okay. Okay, before I go into that, so let me show you how it actually works. Let me show you their docs and then see how cool it is to build. So here's an example. So this is their OpenAI, let's say OpenAI. This is their API reference. For example, it actually tells you how to install OpenAI, pip install, how to get API keys, how do you set up an organization. It tells you every little thing, um, and how do you make a request and stuff like that. So it's very simple to use. Um, for example, I was talking about this chat completion, which we used to create in the RAG. And then this is how you do. Okay, here's the curl command. And then using the OpenAI, and then yeah, we'll go into deep into what these are. But this is usually a simple API command that you hit, and then it actually gives you a response. Okay. Um, and this is the example of an embedding endpoint I was talking about. So you just do a post on this REST API endpoint with your OpenAI key. And then if you put an input as the flood was delicious and the waiter is dot, 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 and then it actually gives you this response, which is a floating point number. Okay, so this has like 1536 floats. Okay, so you can actually see this is the response that you actually get. Okay, it's very simple. You give this, instead of this input, you can actually say I am Steve, or my name is Selva and I work in COVID.co, and then it actually gives you this bunch of numbers, okay, which are called embeddings, by the way. um, and they make it so easy to do this. Okay, and this extensive document in terms of how to use their APIs. So coming back to the session, cool. So let me also reiterate this RAG because this is very relevant to the chatbot as well. So we have a content and then you can actually parse the content. You have to pre-process the content. Again, in terms of pre-processing, there's a lot of techniques. Usually people convert HTML into a markdown. There's some kind of markdown frame a language where it is not heavy with the formatting and stuff like that. And then that's how you pre-process the content. And then you split, basically. Okay. If you have 5 paragraphs, and then every 500 tokens you chunk, basically. And I told you one chunk, one token is 4 characters. So every 500 chunks for 500 tokens, you basically chunk. Okay, you stop, and then you split the basically the paragraphs. Okay, and then you send it to this embedding API, which I showed you earlier. So you put that into an API and you convert it into a bunch of numbers. Okay, very simple to do, and you store it in a vector database. The reason why I say vector database, we also If you're into Gen AI, you need to know this term called vector database. A vector database is essentially that stores strings along with its numerical representation in floating point numbers. That's exactly what it actually does. And when you do a vector search, which means you are taking one vector and you're trying to compare with the rest of the vectors in your database, it has to run a lot of numerical computations. And at scale, the vector database do really good. There's a lot of serverless technology implementation as well in terms of how this technology works. But vector database are a really cool piece of technology. You don't need to store it in a traditional database or in a JSON or a text file. Okay, so this is what you do before you do answering the question. You take all your documents, your PDF, your timetables, curriculum, and everything. You do chunking, you do text embedding, and you store those embeddings in a vector database. Okay, very simple. If you have a small number of text corpus, you don't need to do a vector database. Instead, you store it in a small JSON. Okay, instead of your Python notebook. Sure. And then this is the interesting part when it actually answers the question. So once the question comes in, you got to create embedding for that question. Okay, again, use OpenAI API, which I showed you. Then you do a vector search. Then you calculate for this question embedding, what is the cosine similarity and or Euclidean distance or even dot product. You compute and you pick only the top 5 chunks. Very simple. And you send those top 5 chunks to something called a text completion API, again with OpenAI, along with the question. And then you instruct the OpenAI, the large language model, to answer the question based on the top 5 chunks that is being returned. And then it will beautifully generate an answer for you. It's as simple as that. Okay. And then I'll show you a demo on it, let's say. Um, to give you an understanding of how much it actually cost you, okay, to create an embedding. The An embedding is basically a floating point representation of a text, and it actually costs you $0.02 dollars for 1 million tokens. So you can actually send 1 million tokens and you'll be charged just 2 cents. Okay, that's how much cheap it is. And this it actually returns 1536 floating point. That's the array of numbers, or the length of the vector is 1 by 1536, and they also have a large model which is about 3096, I guess. Okay, so they offer 3 types of embedding models which you can actually use part of your API. Okay, let me show you a quick demo on this. So here is the text embedding that, for example, here is something about ISRO. So ISRO Space Station, Indian Space Research Organization, there is some kind of a text in it. So I'm trying to create an embedding for it. Okay, so let's see what actually happens. So if I run this, so this is what you get. Okay, so you send this data to the API, to the embedding API, and then it actually converted all this text. Okay, the Indian Space Research Organization, India's National Space Agency, headquartered in Bengaluru, Karnataka, and then all the other text, and it actually converts into this floating point numbers. Okay, so the so I can actually see this is about 1536. So that's the dimension of this numbers. Again, it's a bunch of numbers. So there's nothing magical about it. And the way it actually calculates that based on neural networks. Basically, all the embedding numbers are basically the weights of the neural networks in the transformer model of your encoder. So that's what it is. So, cool. So The next thing you have to do here in this example, you can actually send any kind of data to an embedding, but for this demo, I'm going to crawl a website I'm going to crawl Wikipedia ISRO content basically. Okay, so you can actually use any kind of web crawler. You can actually build a small web crawler using any kind of Python packages like Beautiful Soup, or you can actually use some kind of UI based, Selenium based web scraping tool. Okay, so you scrap all the content, then you do something called pre-processing. You remove all the images from the text. You remove all the HTML tags, unwanted CSS, JavaScript, those kind of stuff, and then you only take the raw content. Okay, and then you have to pre-process the content. Again, you can actually chunk the content from 500 to 1,000 tokens. The reason we have chosen 500, again, it's an arbitrary number. You can actually choose 1,000 or 10,000 as well. But the thing is, the more granular tokens you do, you'll have so many chunks, which means it's going to slow down your vector search. Vector search, when you do semantic searching, you have so many chunks to correlate, and then it might introduce noise. So the optimal kind of chunks that is recommended in the literature is about 500 to 1,000 tokens based on your use case. And I actually store all the chunks against each embedding. Very simple. So let me show you how it actually looks like. So here I'm going to scrap all the data from Wikipedia. So again, you actually clearly see it's Wikipedia ISRO site, and I'm just going to scrap, and I'm going to print what I'm actually scrapped. So you can actually see this has all the data about ISRO, um, and then it also has hyperlinks. You actually can actually see in Wikipedia article it has a lot of images, but right now it's all removed. All the hyperlinks are gone, all the formatting and everything is all gone. So you can actually clearly see it actually scrapped all the content from the Wikipedia page of ISRO. Again, you can actually see it's a lot of chunk, a lot of content. Okay, and it is not formatted. Now, here's the important thing. So I'm going to run this chunking logic. Basically, I will take only 500 tokens and then chunk them. Okay, so let's see what actually comes up when I do chunks. So you can actually see it actually chunked. So the first chunk starts from the first line. It's very evident. The second chunk, it says it has supported. So it stopped somewhere and it actually split. The third chunk is this, fourth chunk, fifth chunk, and it goes on. And with that one ISRO article, you can actually see it actually split up into 28 chunks. Okay, 28 chunks of maximum 500 tokens. Okay, very, very simple to actually understand. Now, what I'm going to do is, remember in earlier, I've actually showed you for one of the text we converted into embeddings. For all this 29 chunks, I'm going to create embeddings. Basically, I'm going to take this text data and convert it into an embedding, basically a number of floating point numbers using OpenAI embedding API. So this is what actually happens. So chunked embedding. So you can actually see it's trying to chunk. Sorry, it's trying to create the embedding for the chunk data. It will take a while because it's actually doing it for all the 28 chunks. So you can actually see it does the 28, and then there you go. It actually returned the chunks for all those 28 chunks, embeddings for all those 28. So you can actually see 29, and then there you go. So this is about 29. Okay, so it's very easy. Now, given that I only have a small number of chunks, I'm just storing it in JSON, but in real time, I actually store it in a vector database. Then here's the important thing. So now I asked the question, which mission made India the first country to reach Mars in its first attempt? Now, I'm actually asking a question. So I'm going to convert this question into embedding, something like that. And then I'm going to do the cosine similarity. And I'm going to pick the top 5 chunks. Let's see what top 5 chunks it actually picked. So it actually picked chunk 1. Okay, and then let's look at what's the cosine similarity of that. So you can actually see the score is 0.84. Okay, and it picks the chunk 2 as well. And as mentioned about Mongolian, and you can actually see the cosine similarity score is 0.81, and also picks chunk 3. Okay, pick chunk 4. Okay, and also pick chunk 5. Okay, so in this case, it's a bit sequential, but usually it can pick chunk 1, chunk 28, depending upon the number of question you asked. Okay, and then it was able to answer the question. The Mars orbiter mission, MOM, informally known as Mongolian, made India the first country to reach the Mars in its first attempt. Okay, there you go. It actually answered the question. And now you put all this UI on the top. Now it makes a lot more like a chatbot. Okay, so that's essentially how it actually works in a nutshell. Any question before I go into my presentation? No questions? Great. Cool. So in terms of chat completion, I remember when we asked a question about what's the first India's maiden attempt to reach Mars, and then it was able to pick the Mongolian and then the MOM mission. For that, we use this chat completion API. Okay. So the chat completion API is also extremely cheap. The problem with this chat completion is you have to pay for the input tokens and you also have to pay for the output tokens. When I say input tokens, this is the number of tokens you send as part of your payload. All your questions embeddings, sorry, your questions and the top 5 context. Okay, you're sending all those text that is counted as input. And then the output is how much token that comes out as a response, generated response. And you can actually clearly see ChatGPT's 4.0 latest model, the ChatGPT 4.0 mini is the cheapest. Okay, and it's not limited to sending a text. You can also send images as well using base64. You convert images into base64 and you can actually send it to OpenAI, and you can actually do prompt engineering on the top as well. Okay, so this is a very cool piece of technology. Here's how you can actually use the chat completion API, and you can actually see it's very easy to call. It's a post HTTP method, and you post it to this URL, and then you send your OpenAI API key authentication and stuff like that. And this is very important, the role and all your information that goes. Okay. Um, cool. And here's the one important thing about this. Okay, we can actually define how the chat completion actually works. Okay, and we use something called as a system message. A system message probably sets a guidelines on how this LLM should behave. For example, you go to a site where you can actually instruct the large language model chatbot to behave like a customer service representative. Or in an educational institution, you can actually put a system message saying that, by the way, this chatbot should behave like a lecturer. Okay. So those are the context you can actually provide. And if it's uncertain, you can also put rules on whether how it should behave if it's not uncertain about answering a question. Okay. Here's an example of a system message. Here I can actually say, as a customer support representative, answer a question based on the following rules. And I would say answer should be in this format. You should answer in a particular tone. If the answer is not generated with the context, please respond, I do not know. Again, there are thousands and thousands of rules you can actually put depending upon your use case. Okay, this is one of the typical kind of system message. By the way, this system message are never revealed to end user, and I will show you in a moment as well. And people usually use this something called a prompt injection attack, which is like a prompt hacking, and which is the one new paradigm that is coming up. It's called LLM security. In addition to cyber security, you also test the LLM security as well. Okay. Again, this system message can be tweaked over a period of time. So I clearly mentioned the top five chunks, and you might be wondering why choose top five? Why can't I choose top 10, top 30, or top two? You can also do that. The reason is because we are using this semantic search. The more number of chunks you pick from the bottom, um, you'll have less accuracy. Those information might not be relevant to answering that particular question. So you're actually sending more noise if you're sending more chunks or more context to OpenAI for generating a response. So that's why it's an empirically derived thing, and it's been recommended from the community that we stick with the top five. And I've seen instances where people use top eight or top 10 as well. Again, it depends on a few trade-off. Let's say you have a huge encyclopedia article and you can't chunk them into granular chunks like 200 tokens or 300 tokens, again because it takes a lot of time to compute, to do a vector search, and then it has to generate a response. Okay, and shorter the chunks is, it gives you a macro context, and the longer the chunks is, it gives you the micro context. Basically, it's zooming into a district level, or you zooming out at a country level. Okay, that's the chunking trade-off basically, and it also affects how much time it actually takes you to produce a response. Okay. So there are clear parameters in the chat. Again, I'll show you a demo, but bear with me in terms of this. There are a few parameters in the LLM model, and the first parameter is called temperature. Usually the temperature value ranges from 0 to 1. If you put temperature value as 0, which means it always gives you the highest probability word. Okay, in the next. So here, if you put the temperature as 0, one of the example it says is the scientist discovered a new element on a periodic table. Very, very factual, very clear. If you put the temperature to 1, that's when it start to become more creative. See, now it says scientists discovered a portal to a parallel universe hidden in an ancient library. Sounds like a science fiction to me. Okay, so that's the parameter you can actually tweak, the temperature parameter. If you set it to 1, it gets a lot of it becomes getting a lot of creative, which means it will make up things. And when you put the temperature at 0, it's always factual. It's grounded by truth. And most of the chatbots in the production now, it's been applied, they have the temperature parameter of 0. Okay, cool. And the next one is called maximum tokens. So this is the number of tokens it should import. You can also constrain that. So the maximum token, here's an example. It says a language model predicts and generates text. So the maximum number of tokens they have given is 5 or 10. But if you set the maximum number of tokens to 1,000 or something like that, this is what you get. Okay, now it's a lot more elaborative. And these are the parameters to actually control. Any questions on temperature and maximum token parameters? It's a lot in detail to take in. Cool. I'll continue. So the next one is called something called frequency penalty. This is a beautiful parameter in the large language model. So when you set the frequency penalty to 0, look at what actually happens. It says cats are cute. I love cats because cats are friendly. Cats make great pets. So you can actually see the word cat. It's been repeated multiple times. But if you put the frequency penalty instead of 0 to 1, look what actually happens. Cats are repeated only once. It says cats are cute. I love them because they are friendly, and felines make great pets. See, it's not saying cat again because there's a high frequency penalty. It won't repeat the words. It's boring for a human to read a repeated word. So setting a frequency penalty is pretty good. Okay. And the next parameter in the chat completion API is called presence penalty. Okay, and you can put a presence penalty of certain words. And here, the example I quote is, I love hiking in the mountains. The mountains are beautiful. Hiking is my favorite activity. And you can actually say here, um, mountains. And then you actually say, I love hiking in the mountains. The scenery is breathtaking, and exploring nature is my favorite way to relax. See how it actually changed because of the presence penalty being set to high. And you can actually mix and match all these things. And there's something called stop sequence. And you can actually specify a word where the generated response should stop generating thing after that. So here the word is Paris. The moment it says Paris, it actually stops. If we say the stop sequence is Paris, the Eiffel Tower is in Paris, and after that, it will not generate anything because Paris is the clue word to stop generating any response. But if you set it to none, it starts generating. Okay. Again, with all these 5 parameters, again, these are the one of the coolest parameters I've actually seen. There are multiple parameters as well. You can actually play with all these numbers of these parameters, and you can actually generate a different kind of response. Okay. So now I will show you a live demo. Okay, cool. So again, I'm going into this Chat GPT playground. See, this is the system as I was actually trying to do. And it's already said you are a helpful assistant, but I will say you are a lecturer in, in an university. Answer, okay, answer politely to all the questions. Say hi at the end of every response you generate. Okay, I just trying to put some humor, or just say, yes, just say hi. That will do. And put a lot of rules. If you're unsure about the generated response, just say I do not know. Okay, I'm just setting a very high level. Again, this can be very detailed. So I'm just going to run the some kind of a prompt. Okay, so let me give you a best one. Um, what is quantum theory? Okay, here we go. So I'm running this against the system message. Now it's trying to do this check completion. Now you can actually say, I said the system message, say hi at the end. So see, you actually provided the hi. Okay. Now I'll ask a very complex question. What happens in a parallel universe when photons collide with each other? Universe. Again, it's a very verbose kind of question. Okay, again, it's trying to answer. Again, see, it's actually trying to give a response. Okay, and now I can play with all these temperature parameters. I can actually run this, and um, I would say the maximum token. Let's put this maximum token to this number. Let's say it's only 10. Okay, now I'll ask a question. Um, what is an LLM? Okay, now it actually runs, and see it now. It says an LLM can refer to 2 different things depending, and now it says maximum token limit reached, response terminated. Now it doesn't even obey this command. It says say hi at the end because you set this maximum token parameter to 10. Okay, and those are the parameters I was actually talking about: temperature, maximum token, frequency penalty, presence penalty, and then yeah, those are other kind of parameters again. Okay. Cool. And you can actually choose different models. Right now, I'm choosing ChatGPT 4. You can choose any kind of a model from ChatGPT offering. Okay. as well. So that's pretty much how this actually works in a UI. Again, you can actually replicate the same thing in a chatbot that you build using all the APIs, and you build a cool front end. They also have something as an assistant. Um, Here you can actually create an assistant instead of creating a chatbot on your own. You can create this assistant and it actually exposes an API as well. So that is also available from ChatGPT, okay, from OpenAI basically. Okay, and I covered extensively about OpenAI, but it is not limited to OpenAI. We can actually look at Anthropic Claude. They have the similar kind of APIs compared to OpenAI. And if you just look at Llama 3.1, which is an open source, you can actually run all this on your own server or on your own laptop. Okay, so there's one thing called Olama. Olama. I'll put it on the chat. This is just a small uh, uh, application that you run on your desktop, and you can actually host a lot of models and you run it on your laptop. Sorry. Okay, and there's another called LLM Studio. You can actually install this application and you can actually download all this open source model, and you can actually run a small LLM on your laptop. Okay, if you have some GPUs, it might the number of tokens per second could be a lot more higher. But right now, you don't have to rely on the APIs. You can run it on your local machine as well. So this is the high level overview of how to build a chatbot. That's pretty much I have for this session, and I'm open to answer any question. Yeah, thank you. Happy to take any question on the last session or this session or anything in general, particularly to OpenAI or chatbot and stuff like that. Yeah, and chatbots are going to stay. It's not going away. And there's a cool piece of technology coming up as well. There's a lot of there's a new paradigm called LLM agents, the large language model based agents that can actually do things for you. So imagine in the future, let's say you want to go for a holiday in Goa and you want to book tickets. You just tell this chat GPT, hey, your prompt basically. The prompt is, I want to go to Goa on this particular date. I want to see beaches. I want to have fun, and use tell your hotel preferences and stuff like that. Basically, it will plan your entire travel itinerary. In fact, if you give commands, it can actually go and book tickets for you on your behalf. Okay, and that's the cool piece of technology we're going to do. Okay, and that's going to revolutionize the complete user experience. One example I want to give before I close off in that paradigm is um, so we have so many apps in our phone, Android or iPhone, and there's an app for everything. You have app for Uber, you have app for Ola, you have app for Red Taxi and stuff like that. It's so much overburden for us. In future, you will open your phone and you'll talk to an LLM agent saying that I want to get to the airport fastest. And you don't care whether Uber shows up, Red Taxi shows up, or Ola. You want to go to airport. Okay, quick. So cost is not a constraint. Quick is the keyword. So it'll find the service that can get you there quickest. Probably a Uber auto might show up. Who knows? But if you say I want to go to somewhere at a cheaper cost, then again, some other taxi services might show up. You don't have to decide that. The LLM agent will decide on your behalf. Okay, so that's the paradigm we are actually talking about with this LLM agent, and that's a pretty cool technology to build. And it will completely change the society fabric on how we live and how we run our day-to-day life. But that's exactly where the future is actually going. With that, thank you so much for your time, and make use of all my presentation. And if you have anything, ping me in LinkedIn. Happy to help. If you have any questions right now, I'll open for questions, and then after that, I'll close the session. Thank you. Uh, Priya ma'am, over to you. If you have any question, type it on the chat. Or Okay, excellent. So yeah, anyway, thank you very much for the opportunity. Ma'am, I think that's pretty much I have for the second session, given it's a hands-on session. It's a very simple showcase I just had. It's pretty much I have. Yeah, thank you so much.
Sir, you have covered, am I audible? Covered a lot of ground from understanding the foundational concepts of generative AI to the practical steps